Howdy folks, this is your practice problems video on just the basics of rigid motions as well as translations or shifts, right? So let's go ahead and jump into it here, okay? So for these first couple of questions, I'm dealing with this lovely square right here, okay? So question one says, which of these functions describes a rigid motion? Okay, so for rigid motions, okay, you don't want any multiplication, right? The only exception would be if you're multiplying by -1, meaning changing the sign. So there's two of these that I can eliminate right off the bat, A and C, because they both have a multiplier here, right? The multiplier is going to take the shape and make it either bigger or smaller, right? Bigger if it's a number greater than 1, and smaller if it's like a fraction, okay? Then the only other ones I have left here are B and D. What D is doing, notice you have the X values that stay the same, but the Y values are all turning into the number 3. Okay, so that's basically taking your shape and that would be like turning the shape into like a line because all the Y values would be the same. So that changed the shape, right? Remember, rigid motions can't change the size or shape. So my only answer that I have left is this one, which is a translation, right? I just took my X values and I moved them 3 units to the right or to the left, and then I didn't change my Y values at all, okay? All right, so then 2 here says if the point 0, 3, which is this point right here, is mapped to 0, 0, meaning, so my original point, my pre-image is 0, 3, and my image is 0, 0. Okay, down here. So you have to see what happened to go from here to here, right? And you saw what I drew there in orange. That orange arrow is called a directed line segment, right? It's literally just showing you how far you're going to move and how many and in what direction you're going to move. So if I took this point at the top and moved it 3 units down, then I'm going to do the same thing to the other points. So this point here is going to move down 3 units. This point here will move down 3 units. And this point here will also move down 3 units. So my new square will look something like this. Okay, so the question is, what is the image of 3, 0? So 3, 0 is this point right here. So it got moved down here. So that is the point 3, -3. Okay, so C is my answer there. Okay. All right. Then here we have the same shape, but we want to draw what these look like, what these functions are telling us to do here. Okay, so let's see, let's go with like a bright red here. Okay, so in this first one, my function is, or my output is X. So I'm not doing anything to X. I'm not moving left or right at all, but I have Y plus 2. So I'm going to take my entire shape and move it up 2 units, right? So this point moves up 2 units. Here, this point moves up 2 units. Right? Same thing for these points, right? They're all moving up 2 units. Okay, so my new shape, not drawn very well by me, but that's what it would look like. And since my size and my shape did not change at all, this is a rigid motion. Okay. All right, for part B, I'm taking my X values and moving them 3 units to the right. Okay, so I'm going to take, say, my point right here, and I'm going to move it 3 units to the right, 1, 2, 3, and then 3 units down, 1, 2, 3. Okay, so that's my bottom left corner point. right? And then once you have one point moved, you can just draw what the original shape was, right? So I would go, this side is up 3 units, right? This is a square. I kind of went off my grid a little bit, but that's okay, right? So right 3, down 3. This did not change the size or shape of my figure. So this is a rigid motion, okay? And now this one is definitely going to change some of my values here, okay? So for this one, it's actually going to be helpful for me to do like an input-output table for my 4 coordinate points. So I have my coordinate point here is 0, 0. So this is my input, and this would be my output, okay? So 0, 0. This point over here is 3, 0. Okay, this point up top in the top right is 3, 3. And then this point here is the point 0, 3. Okay, and what I'm going to do is apply this function to it. So I'm going to take all my x values and multiply them by -2. Okay, so 0 times -2 is 0. 3 times -2 is -6. Right, 3 times -2 is -6. 0 times -2 is 0. And then for my y values, I'm going to multiply them by -1/2. Or you can think of that like dividing by -2. So 0 divided by -2 is 0. 0 divided by -2 is 0. Okay. 3 divided by -2 is -1.5. Right? 3 divided by -2 is -1.5. So if I plot these new points here, I'm going to change my color. Okay, so I have the point 0, 0, which is right here, the point -6, 0, which is like way out here, the point -6, -1.5, which is like right here, and then the point 0, -1.5. So this is my new shape right here. Okay, very obviously a different shape, right? I definitely changed the size of the square and the shape of it. So this is not a rigid motion. Okay, and the way that you can tell just by looking at the function is that you have these multipliers here, right? What those do is they either compress your figure, right? So they take it and they kind of smush it together, or it like pulls it apart almost like taffy, right? Which is what this 2 is doing here, okay? All right, so those are just some basics of like figuring out if the shape is rigid or not. And then I'm going to do a couple example problems here for you with translation. So give me a second to clear my screen, and then let's try these translation problems. All right, folks, so here we are. Let's do a couple of these translation type problems, okay? So this first one is kind of like a guided almost example, where it kind of walks you through a couple of different ways that you can look at translations, okay? So what you can see on the screen, on the actual picture, is you see all these arrows, right? Those are your directed line segments. They're telling you how far to move left or right and how far to move up or down, right? So the total distance that you're traveling and how many units you're going to move and in what direction, okay? So here, right, you can kind of connect these endpoints for these 3, 1, 2, 3, because they come directly from the endpoints. This X right here is just kind of like an example of how one point would be moving, right? So I kind of just want to draw my rectangle here, right? So that is my new shape. Okay, and then you can also look at the table where they gave you it's like an input output table that we did in the last one, right? But I'm calling it pre-image and image this time, right? Because that's the correct geometry terms to use. Pre-image is like your before, it's your original image, and then your original figure, and then image is like your new figure, right? Where the points end up after you do the transformation, okay? So we can see it both in the directed line segment and in the table, what happens to the x values and the y values here, okay? So we can see from the arrows, the directed line segments, that I'm moving 2 spaces to the right, which is exactly what's happening in all of these, right? 4 is 2 plus 2. If I do 3 plus 2, I get 5. 1 plus 2, I get 3, okay? And then for the y, right, if you look at the picture and the arrow, the directed line segment, I'm moving 1, 2, 3, 4 units up, which you can also see when you look at the coordinate points, right? If I do 7 plus 4, I get 11. If I do 8 plus 4, I get 12, etc. Okay, so my rule for my transformation, right, the rule for the translation is right 2 units and up 4 units. Okay, so if I wanted to write that as a function, okay, that function would be, my output is x plus 2, right, 2 units to the right, and then y plus 4. I'm doing 4 units up. Okay, if it was 2 units to the left, right, then I would have put x minus 2. Right? If it was 4 units down, I would have put y minus 4. Okay, so that kind of combines a lot of these ideas for translations. Okay, uh, give me a sec to scroll and clear my screen off, and then I'm going to do another example for you like this, and then I'm going to have you try one on your own. All right, everybody. So here is another very typical transformation kind of problem. Whoops. People are texting me. The struggle is real. Okay, so here I am dealing with, let's do like a minty type color. Okay, so in this one, they gave me the function. How very nice of them, right? So it's a lot easier for me to figure out where the new coordinate points are, as well as how to do this visually, okay? So I'm going to do this visually first, and then I'll also do it with the pre-image and image table, so you can kind of see what's happening to the coordinate points, okay? So this is a translation function that says I need to take my x values and move them 4 spaces to the right, okay? So, because it's positive, so I'm going to take my shape and I'm going to move it 4 units this way, 4 units to the right, and then y minus 4 means I'm going to take my shape also and move it 4 units down, okay? So the best thing to do is just pick one of the endpoints, like one of the corner points, right? And then track what happens to that point, right? And then you can kind of draw the rest of the shape around that, okay? So if I'm moving 4 units to the right, 1, 2, 3, 4, and then 4 units down, 1, 2, 3, 4. So my point that was in the top left corner originally was up here, now is down here. Okay, and since I have this is my top left corner point, I can kind of draw my rectangle in because I know that it has to be the exact same size and shape as the original, right? So this had a side length, a vertical side length of 2. So that means I've got another coordinate point down here. And then it was 4 units across, 1, 2, 3, 4. Okay, and then you can kind of draw the rest of those coordinate points in, like the corner points, right? The vertices of the shape, and draw your rectangle in, okay? Then you can verify that you put those vertices in the right place by using the pre-image and image table, because this will tell you exactly where those coordinate points go, okay? So the point -4, 3 is this point that I tracked. So I'm going to take my function and do exactly what it says. So I'm going to take my x value and add 4. Okay, and then I'm going to take my y value and subtract 4. Okay, so -4 plus 4 is 0, and 3 minus 4 is -1. And if you look at that coordinate point, right? That's exactly where the new one is located, at the point 0, -1, okay? So I can do that for all of my other points as well, okay? Add 4 to the x and subtract 4 from the y, okay? Because remember, the rule has to be the same for all of the coordinate points. Otherwise, it wouldn't be a rigid motion, okay? So -4 plus 4 is 0. 1 minus 4 is -3. 0, -3, which is this point right here, okay? 0 plus 4 is 4. 3 minus 4 is -1, okay, which is this point right here that I kind of put a triangle around, okay, and then my last is -4, -3, okay, which is this point right here. So I can verify that I did my my translation correctly because my points for my image match what I drew in my picture, okay? So there's one more here that's very similar to that one. So I'm going to pause the video. I want you guys to do the same. Try this one out and then come back in a second once you're done with it and check your answers against mine. All right, folks, so check your answer against mine. Okay, so my function was xy becomes x plus 3y. Okay, so that means I'm moving 3 units to the right and there's no movement up or down. So I'm literally just taking my triangle and shifting it 3 units to the right. Okay, so you can see I did that visually, right? Where I just took my 3 endpoints and I counted and I moved 3 units to the right. Okay, and I also did it over here with the coordinate points, right? So I'm just adding 3 to all of my x values. So -2, -2 became 1, -2. 1, -2 became 4, -2, and then 1, 4 became 4, 4. All right. So pretty simple, not too scary. Okay. The very last one that I want to do for you here is a translation that's not on a coordinate grid. Okay, where you just have a shape and it's asking you to move it somewhere. Okay. Notice that it says draw the translation TEB. Okay, so that EB is your directed line segment. Okay, it's going to tell you how far to travel and in what direction to travel. Okay, so EB is this directed line segment right here. Okay, so what I'm going to do is I'm going to take all 5 of my coordinate points here, and actually I'm going to do this not with this drawing tool, but with my line tool in Cami, so that you guys can actually see, like, so that it'll be like kind of the same, okay, when I draw these. Okay, so here, right, that is my directed line segment. So I'm going to see if it will let me copy and paste this guy. Nope, maybe not. Okay, but what I can do is I have my directed line segment and I can move it around so that I can see where my new coordinate points are going to go. So my original point E is now going to be here. Okay, my original point A is now going to be here. Okay. So this is, and I really should be labeling these as I go. So if this is A, this new point is A prime. This originally, this point was E, so now it's E prime, right? Because we took this point and moved it over. Okay. Point B originally was here, and now it's going to be at the end of that directed line segment right there. So that's B prime. Point C originally was here, and now it's going to be at the end of this directed line segment. Okay, so that's C prime, and then my last one is point D. Originally was there, and now it's right here at the end of this directed line segment. So that's D prime. And now what I can do is I can connect, like I said, I'm going to do this with my Cami line tool because I can actually draw a little bit easier and connect those dots. Okay, so I have here, and I'm just going to connect those dots. 1, 2, 3, 4, and 5, right? So I just took my shape and I shifted it along this line, this EB line. Okay. Right, so I literally took, right, that's the line EB, and we just moved the entire shape over that far. All right. Okay, so that is it, you guys, on translations. I'll see you in the next video to look at reflections. Bye, y'all.